everyone. This is some example problems from chapter 9, chemical bonds. First example problem: an atom has a nucleus with 13 protons, and that's given, and we know the proton has the number of proton is 13. And the first question is, what is the name of this element? And in order to find the name of the element, we have to refer to periodic table. And if we look at periodic table here, it's the atomic the proton number is 13, and we know proton number is equals to atomic number. That means we are looking for an element that has an atomic number of 13. 1 2 3 4 5 6 7 8 9 10 11 12 and 13. So we know the element name is aluminum and the symbol is Al. Please refer to better the periodic table, a better one, like the one I shared from the Britannica library, which have the detailed name in this periodic table I use for reference. It only has a symbol, not the full name. And then the second question is, what is the valence electron? How many valence electron does this atom have? And as we know, we can find out the valence electron using the group number. And if we look at the periodic table, we know aluminum is in group 13 of the group 13 of the periodic table. And from the rule of valence electron, this is one valence electron for the first group, second group is 2, and after this group 13, this is 13 minus 10, 14 minus 10, and so on. So for aluminum, the valence electrons are 3, or we can also draw this electron configuration, and the first one has 2, second one will have 8. Now total is 10, and the third one is 3. So if we know the atomic number, we can also draw an or electronic configuration and find out the valence electron, or we can simply use the periodic table and find out the valence electron. And the third question is, what is its valency and what does it does it tend to gain or lose electron? And since we saw here the outermost shell has only 3 electrons, and following the octet rule, in order for this outermost shell to have a stable configuration of 8 electrons, it can either lose or gain electron. And if you look at here, in the outermost shell, in order to reach 8 electrons, it either has to gain 5 electrons, or it can lose 3 electrons. So losing 3 electron is more losing 3 electron is possible compared to getting 5 electron, because it requires more energy gain and compared to if it is losing 3 electron. That means valency is 3, and does it tend to gain or lose electron? So in order to gain electron, it has to gain 5. In order to lose it have to lose only 3. So we can say it will lose electron, and if it loses the electron, that means the number of proton will be higher compared to electrons. That means the net charge of this atom will be plus. So we can write aluminium 3 plus, and this is the answer for this question as I write it in an ion form. So aluminium has 3 charges in a, and since it tend to lose the electron, they are positive. Let's look at one more problem here. Predict a bond type between potassium and chlorine. Now we have to predict the bond type between different materials, and if you look at the first problem, this is potassium and chlorine, and we know when we defined this ionic bond and covalent bond, we defined ionic bond as bond between metal and non-metal. So if we look at this element, first we need to figure out where this element are in the periodic table. And if you look at the potassium, the symbol is K. So potassium is here. That means it's in the first group. That means the valence electron is 1. For 1 is implied within here, so we can just write potassium K plus 1, and chlorine is Cl, and we can see here chlorine is right here in group 17. So the valence electron is 7, and if you look at here, since the valence electron is 7, it is easier to gain an electron compared to losing 7 electrons. So this is charge minus, and we also know that except hydrogen, all these elements are metal, and all this metal element here are non-metal, and since potassium is metal, chlorine is non-metal, we can say that this is ionic bond. And also please take note that this periodic table here is, if you are looking at this number, this is electronegativity. And then if you look at the second problem, here hydrogen and oxygen. Hydrogen is the first element, oxygen is the eighth element, and if you look at this element, like we said, hydrogen is, even though it's in group 1 and group 2, this is an exception, and this is not a metal, this is non-metal material, and oxygen is also non-metal, and the chemical reaction chemical bond between non-metal and non-metal is covalent. And for covalent, we also had polar and non-polar and we said this polar covalent bond, the difference in electronegativity so will be between 1 point it was 0.1 to 2. So from 0.1 to 2, if the electronegativity difference is between this value, then this covalent bond will be polar covalent bonds. And then let's see, electronegativity of hydrogen is given here 2.2. Electronegativity of oxygen is given here 3.44. The difference is 3.44 minus 2.2 is equals to 2.2 1.22. That means this is polar covalent. Sorry, this will be 1.24, not 22. And then the bond between carbon and bromine. Carbon is here, again non-metal. Bromine is bromine Br is here, again non-metal. So the bond between non-metal and non-metal is covalent. And if you look at the difference, 3.44 electronegativity is 3.44 and 2.96, and the difference is 3.44 minus 2.96 is 0.48, which is bigger than this number. So this is also polar covalent bond. And one more example, I use the crisscross method to determine the chemical formula for calcium and nitride. And first, please refer back to a periodic table which has this full name of this element. For now, I will refer to this table here, and we would need to determine the chemical formula for calcium nitride. And if you remember the naming convention of this ionic material, ionic compound, we said first element plus second element, but the name will be in the form of "ide", right? And this was the naming convention for this kind of material. That means this will be a combination of calcium and nitrogen. And if you look at the periodic table, calcium is here with an atomic number of 20, and if you look at nitrogen, nitrogen is here and with an atomic number of 7. And since calcium is in group 2, the valence electron is 2, nitrogen is 7, and this is in group 5. That means there are 5 valence electron, and it can either gain 3 electron or lose 5 electrons. So it is easier to gain to lose 3 electron, to gain 3 electron, because there are 5 electron in the valence shell, resulting in 3 plus charges. Now if we do the crisscross, it will be calcium, nitrogen. Calcium has 2 charges, nitrogen has 3 charges. And then we will assign this to corresponding side, the opposite side. Then this will be calcium 3, nitrogen 2. And also remember, this name is nitride. If the name is different, for example nitride, it will be completely different element, so you have to be careful how it is named. Then let's look at another example, aluminium oxide. And then again, this is first element, so aluminium is here 13, atomic number is 13. Then oxide, then again this is IDE form, so this was changed from oxygen. Oxygen is 8. That means the valence electron in oxygen is 6, so it will gain 2 electron. Aluminium is valence electron are here. Aluminium is here, so valence electron is 3, and instead of it can either lose 3 or gain 5, so it will lose 3 instead. Now we know the charge on both of the elements. Now we can use the crisscross. Aluminium has 3 charges, oxygen has 2 charges. Now we will assign these two oxygen, these two oxygen and these two aluminium. Then our structure will be aluminium 2, oxygen 3, and this is aluminium oxide. Similarly, more example problem. Name the covalent compound. Using appropriate prefixes. Now the naming convention for covalent compound was prefix plus first element then prefix plus second element, and the second element will be in IDE form. So this is, now the first element is there are 2 of the first elements, so it should be di. And if you look at here, for the second one there are 5, so penta. Now also if you go back to the periodic table and to look for the name of the element with symbol P, it's phosphorus, and the atomic number is 15, and O is oxygen, atomic number 6. So if we want to name it now, it will be, so this is phosphorus and there are 2, so diphosphorus, and then there are 5 oxygen pentaoxide. From oxygen it will be oxide, so the name is diphosphorus pentaoxide. Similarly here, this is nitrogen di, and then oxygen there are 4, and for 4 this is tetra, so this is dinitrogen tetraoxide. Similarly here again, this is phosphorus and this is chlorine. So phosphorus is 1, which is mono, and we said that the first element, if it's a mono, we don't have to write it because it's implied by itself. So we can simply say phosphorus pentachloride.